the numerical we have solved, and we have calculated the depth of the stem. Okay. So what is the meaning of depth of the stem? That I will tell you here in short. So stem means what? This portion of the retaining wall. Okay, so this portion. This is called as stem. Okay, ह्याच्या खाली तुम्हाला इथं बेस स्लॅब असणार आहे. तो hill will be there and toe is there. So we have assumed this width as 0.2 meter, and we have calculated this. It is at 0.4 meter. That is 400 mm. We have calculated 400 mm. Okay. So now, if you see the further, if I complete this diagram, then it will be like this. Okay. And here is the toe end. This is the typical structure of retaining wall. Okay, this part we called it as toe, and here this part we called it as hill. Okay, so now whatever may be the thickness of the stem at bottom, same thickness is provided for the base slab. Normally it is done. Okay, so this is called as base slab. This together is called as base slab. Okay, so for stem, whatever may be the this thickness of the stem, that thickness is provided to the base slab also. Okay, 0.4 meter. So yesterday we have designed the stem, and we have provided thickness of stem at bottom is equal to 400 mm. Okay, therefore the depth of base slab is equal to how much? Same we are going to provide. So it is also 0.400 mm, which is 0.4 meter. Okay, so up to this point we have studied in the last lecture. So now we will move further to this. So now, what will be the total height of the wall? Okay, so now if you see, 5 meter is the height of the wall. So 5 meter तुम्हाला कुठून दिलेले आहे 5 meter? So 5 meter is from this point. Okay, from this point up to the top. This it is given as 5 meter. Now what will be the total height? If I talk in terms of total height, then this will be this much of distance total. So what is this total? So this is 5 plus 0.4. So this height will be 5.4 meter. Okay. This height will be 5.4 meter. So I will write here total height of wall. It is capital H. Notation is capital H. For this height, I will use capital H notation. This is the height from the top of the base slab. It is small h. It can be denoted by small h. The total height is equal to, it is 5 plus 0.4, which is equal to 5.4 meter. So this is the total height. Okay. So now width of base slab. Okay. So to provide the width of base slab, there is some criteria. Okay. So width of base slab means what? Width means this is the distance. See, if you measure this distance, this is called as, this is your width of base slab. It is denoted by letter B. So I will write here width of base slab B is equal to B is equal to it is taken as, it is taken in between 0.5 h to, I am writing here capital H and total height 0.5 h to 0.6 h. So the base of this width of this base slab, it is taken in between 0.5h to 0.6h. So B is equal to, do the calculation, 0.5 into 5.4. 5.4 means 2.7. So 2.7 meter, or now it is 2.6h. So 0.6 into 5.4. So it is near about 3.2. Okay, 3.2 meter. So now your width of base slab should be in between 2.7 meter to 3.2 meter. So from 2.8 to 3.1, you can choose any width of the base slab. So you can choose 2.8 meter, you can choose 2.9 meter, you can take 3 meter, or you can take 3.1 meter. Okay, so we will take the middle value 3 meter. Let us say we will take 3 meter. Okay, so taking width B is equal to 3 meter. So we have taken this as a 3 meter. Okay, we have taken this as a 3 meter. Now, after this base, this is called as toe projection. See, this is the this distance. This point is called as toe, and this is called as toe projection. Okay, this length, toe projection. Here I don't have the space to write the name, but here on this side you can see this is called as toe projection. हे जे काही distance आहे पुढे आलेला टोचं जे distance आहे, this is called as toe projection. So for toe projection can be taken as 1/3 of the width of base slab. Okay. So here toe projection is equal to 1/3 into width of base slab. So it is 1/3 into width of base slab is 3 meter, which is equal to 1 meter. So this is 1 meter. Okay. So we have got this 1 meter. Now what is this remaining? Now we need to calculate this remaining thing. Okay. This is the distance of hill slab. Okay. So how much it will be? So 3 minus 1.4. This is 0.4, no? So this will become how much it is? बघा हे किती आहे? 3 आहे. See, this total is 3. 3 minus 1, 2 meter. 2 minus 0.4. So it is how much it is? 1.6. So this remaining is 1.6 meter. If you add all of these, 1 plus 0.4 plus 1.6, you should get base as a 3 meter. Okay. So now we will make the stability calculations. So what is the meaning of stability calculations? So in the stability calculations, we calculate the centroid of the all the forces which are acting on the retaining wall. Okay, and we will see that the geometrical centroid of the retaining wall and the force centroid of the retaining wall, are they are acting on the same side, or there is some eccentricity? Are you getting my point? एक रिटेनिंग बॉल आहे, त्या रिटेनिंग बॉल वरती n नंबर ऑफ फोर्सेस ऍक्ट व्हायला लागलेले आहेत. P1, P2, P3, P4, P5 अप्लाइड मेकॅनिक्स मध्ये तुम्ही शिकलेला आहे. तर या फोर्सेसचा तुम्हाला कुठेतरी सीजी मिळणार आहे, सेंट्रॉइड मिळणार आहे. ओके, अँड सिमिलरली तुम्ही जर ती कॅन्टिलीवर बॉल जर बघितली तर इट कन्सिस्ट ऑफ स्टेम, base slab, toe projection, hill is also there. So there is some geometrical centroid. जसं तुम्ही रेक्टँगल म्हणला तर रेक्टँगलचा सेंट्रॉइड कुठे येते? b/2 t/2. Okay, so loading centroid is the different concept and geometrical centroid is the different concept. सगळ्या लोडचा जो एक काही सेंटर पॉइंट मिळतो, that is your loading centroid, and geometrical centroid, you know that. Okay, we have already studied in detail. So whether we are going to see in the stability calculation that our force or loading centroid and our geometrical centroid, they are coinciding, lying on the same point, or there is some eccentricity in between those two. And if the eccentricity is there, then we have to consider direct stresses as well as bending stresses. P by A plus M by Z. That is the basic formula. Okay. So now, moving further, I will draw the diagram first so that it will be easier for you to understand the things known to you. So much more dimensions. I will show the dimensions afterwards. First of all, I will give you the heading here, stability calculations. So I have already told you what we are going to do here, stability calculations. So we will calculate eccentricity, whether it is in the permissible limit or not. The permissible limit for eccentricity is b by 6. Okay, it is b by 6. It should be under b by 6. So now, see how many types of loads will be there. First of all, the self weight of this retaining wall is there. To calculate the stability, you need to consider the moment of the self weight of this retaining wall plus the soil surcharge pressure which is resting over here. Soil will be resting over here. Okay, up to the base. Soil will be resting. So that soil pressure also you need to consider. So for that purpose now, what I will do, so here I will divide this retaining wall into certain areas, definite areas, so that we can easily calculate the dead load or the weight of the retaining wall. So if I drop the perpendicular from this point, so if I drop the perpendicular from this point, this is the perpendicular to the base, and if I join this point, then it will be like this. If I join it, it will be like this. Okay, so this is my first area. This is first area which is rectangle. This is the second area which is triangle. This is the third area which is again rectangle. Okay, now next is the pressure. See, the soil is there, so soil pressure is also acting. So here the soil pressure is acting like this downward. Okay. This is the soil pressure. So if I will give you the name, let us say that this is W1, this is W2, this is W3, and this is the backfill soil pressure WB. डाउनवर्ड पण असणार आहे ना, सॉइलचं वेट पण असणार आहे याच्यावरती. सो सॉइल विल बी ऍक्ट लाईक दिस, अँड इन ऍडिशन टू दिस there is a active earth pressure. So this soil will exert the pressure in this direction also. Okay, this we have already studied in geotech. So this is called as active earth pressure, PA. Okay, and now these are the forces which we have shown over here. They will act to the CG of the respective areas. Okay, they will act to the CG of the respective areas. Suppose now CG of this rectangle is here somewhere. Okay, then the CG of this base slab is again somewhere here. CG of the rectangle is again somewhere. The triangle is again somewhere here. So this is your W3. Here it is your W2. Okay. So if I show the direction of the forces from where those are acting, so W1 it will act like this to the CG. W2 will also act to the CG, and W3 and W2 also act to the CG. So these are your forces W1, W2 and W3. Okay. So to calculate the stability we will take, आता आपल्याला काय करायचं तुम्हाला सांगतो, हे जे सगळे एरियामध्ये तुम्ही डिवाइड केलेले आहेत या फोर्सचा तुम्हाला कुठेतरी सेंट्रॉइड मिळेल. Okay, you will get the centroid of all these forces, okay, from a single reference point. So we will take the moment of all these forces about this point. Let us call this point as A point. Okay. From this A point, we will take the moment of all these forces and we will calculate the position of centroid of all these forces. And then we will check for the eccentricity. Okay. So I will write here take moment of all forces about point P. Okay. So now we will do one table so that the calculations will be easier for us. So first here loads. Okay. Then it may not be possible to use the pure view. First loads, then magnitude. What is the magnitude? After that, distance from point A, distance of the force from point A, and moment. Now keep the calculators with you and I want the values quickly. So magnitude we will take in kilonewton, distance we will take in meter, so the moment will be in kilonewton meter. So your first load, so I will draw the lines. This is our table. Okay. So now our first load, it is W1. W1 is equal to. Now if you go over here W1, so this area is W1. Okay. Now how to calculate the weight of this W1? So now here you can say that this is your 0.2 meter. Okay. And this height, it is 5 meter. At this side from this point up to the end. So this I am talking about this side from this point to this point. This is 5 meter. And this is made up of concrete. Retaining wall है ना, concrete वापरणार तुम्ही. So it is made up of concrete. So what is the area? 0.2 into 5 into 25. So I will get the UDL in magnitude in kilonewton. Okay. 0.2 into 5. So 1 meter length we assume. So now it will be 0.2. It will be 0.2 into 5 into 25. This is the load. So what is the value of this? It comes 5 to the 10, 25, 25 kilonewton per meter. Now the distance from point A. Now this is the important thing. The distance from point A. How do we take the distance from point A? How it can be calculated? So A point is here. So at this point A is here somewhere. Okay. So now your load is here. So म्हणजे distance कुठलं distance पाहिजे तुम्हाला? You want this much of distance. I will show here with the arrow. I will take different color. Let us take black. So from this point up to here, this distance you want. Distance from point A. So because we are taking the moment of all the forces about point A. So now how much is that distance? So this is already known to us. This is 1.6 meter that we have already calculated. Plus त्याच्यात तुम्हाला किती करावं लागणार एवढं प्लस करावं लागणार एवढं distance. You need to add this much of distance. So if this total is 0.4, so this total is 0.2 now. See, we have divided this into rectangle. So if this is 0.2, then half of 0.2 because W1 will acting at the centroid of this rectangle. So if this base, this total stem is 0.4, out of that, if this is 0.2, then this rectangle's base is 0.2 and the remaining 0.2 will be the triangle's base. So rectangle base is 0.2 and it's half, so it will be 0.1. Okay, so I will write, so it is 1.6 is 1.6 plus 0.2 by 2, so it will be 1.7, and the multiplication of these two is 42.5 kilonewton meter. What is the direction? It will move in anti-clockwise direction. Okay, so direction, for your convenience I am telling over here, there is no need to take the plus minus right now, we will take it afterwards, or even though if we take it over here there is also no problem. This is anti-clockwise. Okay, I will show the direction over here, anti-clockwise. Okay, so now the next thing, next load W2. So W2 is triangle. If you see W2 is triangle. What is, how do we calculate the area of triangle? Half into base into height. So what is the base of the triangle? This is 0.2. हे टोटल 0.4 होतं, त्यातला अर्धा भाग कोण घेतलं? रेक्टँगल 0.2, कारण वरची स्टेम 0.2 आहे, त्यामुळे हा बेस पण 0.2 येणार, म्हणजे हे राहिलं किती परत 0.2. आणि ही हाईट किती आहे? व्हॉट इज द हाईट ऑफ दिस रेक्टँगल? इट इज 5 मीटर, कारण टोटल हाईट 5.4 आहे. ओके, आणि हे जे आहे ते 0.4 मीटर आहे, म्हणून टोटल हाईट 5.4 आहे. आपल्याला टोटल हाईट नको आहे, रेक्टँगल ट्रायंगल कुठे आहे? हा या पॉइंटला इथनं पाहिजे हाईट, सो इट इज 5 मीटर. Okay, so now W2 is equal to, it is half into base 0.2 into height is 5 into density of concrete 25. It is also made up of concrete, so its value is 12.5 kilonewton. Okay, and now the distance from point A. The point A पासूनचं distance पाहिजे तुम्हाला. Okay, so I will draw another separate diagram for this. See, here your W2 is acting. Okay, I will draw the separate diagram. Here W2 is acting, and here somewhere your point A is there. Okay, मग हे डिस्टन्स तुम्हाला पाहिजे, तर इथं तुमचा टो एंड आहे समजा, हा याला मी या पॉइंट, हियर इज सम वन पॉइंट. ओके, सो दिस पॉइंट सपोज नाउ इट इज ओव्हर हियर. हे डिस्टन्स तुम्हाला ऑलरेडी माहिती आहे 1.6 मीटर. ओके, प्लस हे पुढे किती येणार? 0.4 मीटर. सो अगेन प्लस this is 0.2 meter, not 0.4, 0.2 meter. Okay. Now this triangle, the centroid of the triangle is at a distance of what? B by 3 and H by 3 from right angle. Okay, so B by 3 and H by 3 means what? B by 3, so base is 0.2, so this will be 0.2 by 3. So if I want to calculate the total distance from point A, so the distance will be 1.6 plus 0.2 plus 0.2 by 3. Because if you consider this triangle, अगर तुम्हें triangle ऐसा consider केला, if you consider this triangle, CG may be somewhere here. This is the position of your W2. Okay, and this height is 5 meter, and this total width is 0.2 meter. Okay, that is why the load is half into base into height W2, and then CG from right angle. Suppose now this is right angle, then this distance will be, this is your B by 3. So it will be 0.2 divided by 3. Okay, so now this already you have learned. Still I have told you for a single calculation in detail. So now you will be able to understand the rest of the calculations. So it is now 1.6 plus zero point 0.2 plus 0.2 by 3. So this is works out to be 1.866. Again calculate the moment. It is 23.33 and again it is moving down, so it is anti-clockwise. Okay. Next thing is W3. So now if you see W3, W3 is very simple. It is a rectangle. This is your W3. So this width is 3 meter. जे आपण मगाशीच बघितलं ना, this total is 3 meter and this is 0.4. So the area will be 0.43 into 0.4 into 25, and the distance from point A will be, if this total is 3 meter, then it will be half of that. So it is 1.5 meter, 3 by 2. Okay. So here I can write this rectangle. So 0.4 into 3 into, again it is made up of concrete. So 25. It is 30. एवढं कशासाठी करतोय आपण सगळं? स्टॅबिलिटी चेक करायला. स्टॅबिलिटी चेक म्हणजे काय करायचं आपल्याला? या सगळ्या ऍक्ट होणारे लोड ह्यांचा सेंट्रॉइड आणि जॉमेट्रिकल सेंट्रॉइड ऑफ रिटेनिंग वॉल ह्यांच्यात इसेंट्रिसिटी आहे का नाही हे बघायचं. कारण इसेंट्रिसिटी जर वाढली तर ओव्हर टर्निंगचे चान्सेस जास्त वाढतात. ओके. सो नाउ here 30, and what is the distance? It is 3 by 2. Which is 1.5 meter. Okay. So if you again calculate this, 330 into 1.5 is 45, and again it is anti-clockwise. Again it is anti-clockwise. Now let us move back. So now W1 is over, W1 झालं, W2 is also over, W3 is also over. Now take WB. WB म्हणजे काय? इथं जी काय सॉइलचे पार्टिकल्स आहेत. Okay. Here whatever may be the soil particles are there, here the soil is present. Okay, इथं soil आहे सगळीकडे अशी. Soil presence is there. So that weight of soil will also cause some movement about point A. Okay. हा एरिया किती आहे? हा एरिया जर मला बघायचा असेल किती आहे, तर हे बघा, हे किती आहे? दिस इज 5 मीटर and this is 1.6 मीटर. सो म्हणजे हा जो रेक्टँगल असणार आहे एवढा सॉइलचा, हा किती असणार आहे? 1.6 मीटर बाय 5 मीटर. ओके. And this is the soil. So what is the density of soil? Now you should not take 25 because 25 is the density of concrete. Now for soil 18 is the density of the soil. Okay, so that we will take now. If you won't understand any point, let me know at that point only before going further, so that we can resolve it quickly. So WB, soil backfill pressure, it is, how much it is? It is 1.6 into 5 into 18. Now density of soil is 18. So 18 will be, it is 144. This is 144. Okay, and its CG will be half of 1.6. So it is 1.6 by 2, which is equal to 0.8 meter. I hope now your CG's concepts are very clear. आणि तुम्हाला काढता येते डिस्टन्सेस सगळे असं मी घेऊन चाललोय. So now the moment will be 115.2, and this moment is also anti-clockwise. And lastly, the remaining thing is that this PA, active earth pressure, which you know the formula, it is half into K into gamma into H. This K into gamma into H is the base, so it will be here half into, so I will put the values K 0.33 into gamma is 18 into H is 5.4 square. This is the active earth pressure. Okay, and then its value is 86.60. This is horizontal pressure. Huh? All these above four pressures are vertical, but this is horizontal, and its Cg will be at h by 3. So it will be 5.4 divided by 3. Here its Cg is situated. It is 1.8 meter, and now this value is 155.899, and this will also rotate in anti-clockwise direction. But the thing is that all these forces are vertical forces. This force is vertical, this second is also vertical, third is also vertical, fourth is also vertical, but passive earth pressure is horizontal. Passive earth pressure is horizontal. So here in doing the algebraic sum of the forces, we won't consider this what we can say passive earth pressure because it is horizontal. So now calculate the total of this. If you calculate the total म्हणजे कशी calculate करणार तुम्ही 25 plus 12.5 plus 30 plus 144. So it will become summation f is equal to 211.5. Varignon's theorem आपण वापरणार आहे CG काढायला आपलं eccentricity काढायला. Okay, and now sum of the moments. So add all these values because all are anti-clockwise. So it will become it is 381.91. Okay. So it is 381.91. So now here we will calculate this. Here I can write the distance of point of application of the resultant force, the distance of point of application of the resultant force from point A. How to calculate this from point A? You know that summation f into x is equal to summation m. Okay, summation m is equal to summation f into x bar. Okay, so therefore x bar is equal to आता हे कुठून आलं तर हा Varignon's theorem आहे जो तुम्ही फर्स्ट इयर मध्ये शिकलेला आहात. Okay, you have studied this in first year. Then therefore x bar is equal to it is summation m divided by summation f. So summation m is 381.91 and summation f is 211.5. So if you solve this, you will get 1.81 meter. Okay, 1.81 meter, but most importantly, it is from point A. तो ए पॉइंट पासून म्हणजे ए पॉइंट पासून लोडिंगचा जो सीजी आहे तो किती डिस्टन्स वरती असणार आहे It is at a distance of 1.8 मीटर. म्हणजे इथून जर डिस्टन्स घेतलं तर या ए पॉइंट पासून एवढं डिस्टन्स असेल त्याचं. हिअर समवेअर. Here is the resultant of loading. It is at a distance of 1.81 meter. So if I show you here the big arrow, it will be like this. This is the, what we can say, loading. Okay, but now see, if this total is 3 meter, so where is the centroid of this figure? It is nearly at the center. So centroid of total figure will be somewhere here. Okay. And what is the distance of the centroid of the total figure? So the distance of the centroid of the total figure, it is 1.5 meter, because this total is 3 meter. This is 1.5 center. Okay. So how much is this eccentricity? So whatever may be remaining now, so this remaining thing, this is the eccentricity E. Whatever may be remaining now, this is the eccentricity E. Okay. So therefore, your eccentricity E is equal to 1.81 minus 1.5. So that eccentricity is 0.313 meter. Eccentricity should be less than b by 6. Okay. So you have studied this concept of kern of the section. Okay. There is some portion when there is a uniaxial, biaxial condition or the loading which is eccentric about x-axis as well as which is eccentric about y-axis, then there is one condition or one zone where you will that is called as no tension zone, that is called as kern of the section. In that zone, if the force is acting, then only positive stress will develop, that is the compressive stress. No tensile stress will develop. And that kern of the section or that distance, it is for rectangular section, it is b by 6 and d by 6. ऐकले असतील तुम्ही टर्म थर्ड इयर सेकंड इयर मध्ये फॉर्म. So it is b by 6 and d by 6. So your eccentricity should not be greater than b by 6 here in this case. So now we will calculate the value of b by 6. Therefore, b by 6 is equal to, now b by 6 is equal to, b is 3 meter divided by 6, so it is how much? 0.5 meter. So b by 6, 0.5 meter, up to 0.5 meter is allowed, but our eccentricity is 0.313. So therefore E is equal to 0.313 meter, which is less than b by 6, which is equal to 0.5 meter. Hence okay, hence it is okay or safe. I hope now you understood up to this point. Stability check म्हणजे high stability check. Okay. And if your stability check is not getting satisfied, then you have to revise your width of the base slab. Okay, width of the base slab. So now here the condition is getting satisfied. Okay, so now extreme pressure intensity at the base, that we are going to calculate. Now you know that the retaining wall retains the soil. Okay, it is good, but retaining wall also resting on the soil. बरं का, रिटेनिंग वॉलच्या खाली काय फाउंडेशन केलंय किंवा काय केलंय असं नसतंय. हार्ड स्ट्राटा असतंय. हार्ड स्ट्राटावरती कॉन्क्रीटचं बेड आपण टाकतो आणि त्याच्यावरती रिटेनिंग वॉल उभं करत असतो. सो रिटेनिंग वॉल इट डायरेक्टली ऍक्ट बाय द अपवर्ड प्रेशर फ्रॉम द सॉइल. जसं फाउंडेशन आहे ना तुमचं, फाउंडेशन ऑन द फुटिंग देर इज ऑलवेज अपवर्ड प्रेशर फ्रॉम द सॉइल. अपवर्ड प्रेशर इंटेन्सिटी वी कॉल्ड इट एज soil pressure. Similar way, retaining wall also faces the upwards pressure intensity from the soil. Okay. So that upward pressure intensity we will calculate. So now here our eccentricity is within the elastic limit. So I will write over here extreme pressure intensity at the base slab of wall is, what is the extreme pressure sigma intensity? It can be calculated as sigma is equal to फॉर्म्युला पण समजेला आहे तुम्हाला. Okay. So sigma is equal to W by B in bracket 1 plus minus 6 E by B. Okay, so plus minus sign is for sigma max and sigma minimum. Okay. So जास्त काही लक्षात येत नसेल तर सरळ समजून घ्या, हा फॉर्म्युला आहे P by A plus M by Z, P by A minus M by Z. Okay, so this is the formula which is given over here. So if you put the values, then it will be 211.5 W your load. Okay, calculate केलेला आहे आपण ऑलरेडी. Summation F divided by 3 in the bracket 1 plus minus 6 into eccentricity 0.313 divided by B is 3. Therefore, now I will directly write here the value of sigma max and sigma minimum. Let me know these two values. Sigma max is equal to 114.63 kilonewton per meter square. Sigma minimum 26.367 kilonewton per meter. These are the only intensities. So ultimate pressure intensities are multiply this by 1.5. Or else we will multiply it when we will solve it. So let us keep it as it is. Afterwards we will multiply it. आता केलं तरी चालतंय. So now, so this is the our stability calculation. इथं तुमचा एक पार्ट संपला, stability check or stability calculation. Okay. So here your first part ends. Stability calculation. So the basic of this part is you should check the eccentricity whether it is greater than BY6 or less than BY6. The second thing is now design of stem. So now we need to design the three things. Stem we are going to design. Okay. Then design for the toe slab and design for the heel slab. These things we are going to do. Okay. So now here design of stem. What is the maximum bending moment? Yesterday we have calculated. Mu for stem is 187.5 kilonewton meter. Overall depth of the stem 400. So here I will write assuming effective cover of 40 mm. Therefore, effective depth will be 400 minus 40, which is equal to 360 mm. This is the effective depth. So now calculate the area of steel. So AST is equal to, you know this formula, copy down this and let me know the answer. Okay, so the answer is 1588.76. Okay, 1588.76 mm square. This is the area. Now provide 16 mm diameter bars. Okay, and calculate the number of bars. Provide If you provide 16 mm diameter bars, then number of bars is 1588.76 divided by 5 by 4 into 16 square, 7.9. 7.9, so we will provide 8 bars, 8 numbers. Okay. So now 8 number of bars we are providing, so calculate AST provided. One six zero eight point four nine. 1608.49 mm square. So this is our AST provided. Now calculate the spacing. Spacing SV is equal to, how do we calculate it? Area of single bar divided by AST provided, 1608.49 into 1000. What is the answer? 125. Okay, exactly 125. Okay, so 125 mm center to center. So here we can provide these bars. So provide 8 bars of 16 mm diameter about 125 mm center to center in stem. Okay, this is your main stem. So in the another direction, we will provide the distribution stem. In the stem, in other direction, we will provide distribution stem. This is design of stem. Distribution stem ASTD is equal to 0.12% of gross area. So it is 1000 into, it is 400 base slab. So it is 480 mm square. Okay. So assume 8 mm bar diameter. Assume 8 mm bar diameter. So calculate the number of bars. Number of bars is equal to 480 divided by area of single bar. Calculate the number of bars. 9.54. 9.54, which is rounded up to 10 numbers. Now calculate ASTD provided. 10 bars we are going to provide, each of bar diameter 8. So 2.65. Okay. So it is 502.65 mm square. Okay. Now calculate the spacing. Spacing S is equal to, it is 5 by 4 into 8 square divided by 502.65 into 1000. Calculate it. 100. Okay. So 100 mm center to center. So here provide 10 bars of 8 mm diameter about 100 mm center to center. Okay, in stem. So this we are going to provide in stem. First is also stem. So this is the design of stem. Okay. आणि तुमचं जे स्टेम आहे तर त्याची मेन डायरेक्शन कुठली असणार आहे, वर्टिकल डायरेक्शन असणार आहे. सो इन द स्टेम your main steel is of about 16 mm bar diameter, 125 mm center to center, and distribution steel is 8 mm bar diameter, 100 mm center to center. Okay, so this is the design of stem. Now we will move to next design of toe slab. Okay. Design of toe slab. So while designing the toe slab, bending moment calculations for 1 meter wide strip of the toe slab is done. So toe slab is considered of assuming 1 meter, our regular assumption, assuming 1 meter wide strip, wide strip for toe slab. Okay, assuming 1 meter wide strip for the toe slab. So again, I will do two parts over here. First, let us distinguish me both the parts. So on the left hand side I will draw the diagram. On the right hand side we will prepare the table. आपल्याला जसं आता आपण स्टॅबिलिटी चेक लागतं आपल्याला टेबल तयार करायला तसंच आता इथं पण टेबल तयार करावं लागेल आपल्याला. Okay, so here I will draw the diagram quickly. So this is the stem. I am drawing the retaining wall again. You also draw the diagram. Now I will show the soil pressure below this. Okay. Now for showing the soil pressure, this is the baseline. Okay. And now we will see the maximum and the minimum soil pressure. What we have calculated the soil pressure. Soil pressure was sigma max. It is 114.63. So multiply it by 1.5. What is the value? 114.63 multiplied by 1.5, that is your maximum soil pressure, and here it is minimum soil pressure. So sigma max, here is your maximum soil pressure, and here your soil pressure is minimum. Okay, so this is your soil pressure. If I draw the arrows, it will be like this. So let me know the answer. Ultimate soil pressure. Okay, ultimate sigma max. It is किती आलं होतं आपलं आधीचं सिग्मा मॅक्स and सिग्मा मिनिमम, त्याला 1.5 ने मल्टिप्लाय करा. So it is ultimate value we want to calculate now. So here it is 1.5 into 114.63, and ultimate sigma minimum is equal to, it is 1.5 into 26.36, 367. Let me know the values. It is 171 and 39. Okay, so I will write over here first. So this value, it is 171.94 kilonewton per meter square, and this value 39.54 kilonewton per meter square. Okay, so here, so I will erase this now. So these are the ultimate values.
म्हातारीला बी खाकडायचं खाली
Roll number 6, mute yourself. Roll number 6. So now here again, load, again load, then magnitude, distance from point B, from point B. Okay, so now your B point, so now it is not distance from point, let us say that it is point C. So distance from point C, and we will give that point as C name. So this is our C point. This point is this point over here, which is on this line. This is our C point. Okay. And moment, kilonewton meter. Okay. So first, upward pressure. First is the upward pressure. Now you can see if I project this, this is our point C. Okay. So if you project this over here, we need to calculate what is the pressure at this point. Okay, what is the pressure at this point? This we need to calculate. How we are going to calculate now? If this total is 3 meter, okay, first we need to divide this trapezoidal into the triangular shape, and then we have to calculate this ordinate. Okay, and now what is the upward pressure? Upward pressure will be this pressure. Whatever you are seeing over here, this area, whatever may be the rectangular area corresponding below corresponding area of the soil will exert the upward soil pressure. Okay. So it is now, जर तुम्हाला दाखवायचं असेल तर suppose this is our trapezoidal. It is like this. So किती आले त्यांच्या व्हॅल्यू 39.54, 170, 1.90. So this is your 39.54, 171.94, and this total base is of 3 meter. Okay. O, suppose from O, if you go at a distance of 3 meter, your intensity is 171. Okay, but where we want it now? We want it at point C. So from this point, this is our O point. Suppose now this point. From O point, how much is the distance of this C point? If this total is 3 meter, this projection we know 1 meter, so this remaining will be 2 meter. Okay, so here I can say that if I drop the perpendicular, it will be like this. So this much of distance, this will be 39.54. Now if I consider this triangle, this O, suppose now this is point A, here it is point B, this triangular point is C, and this is point D. So if I consider this triangle now, this triangle, so this is D, here it is B and C, this angle is 90 degree. Okay. So this total is 3 meter, and now what will be this ordinate, this end ordinate? So this ordinate will be, how much it is? Do the calculation. 171.94 minus 39.54. 132.4. So this is 132.4 at a 3 meter. Now we want at a distance of 2 meter. Now what is the ordinate over here at a distance of 2 meter? That we need to find out. Simple. Okay. So for 3 meter it is 132.4. For 2 meter it is x divide equal to. So therefore x is equal to, what is the ordinate now? This is our x. What is the answer? So we want somewhere here total ordinate up to 2 meter. It is 88.26. So x is 88.26. म्हणजे काय total ordinate झाला का नाही? Only this ordinate is 88.26. So it is in DBC. So DBC, if you see, if I project this ordinate, only this much of ordinate, this is 88.26. Okay, then this ordinate from this point, this is already known. And here this is 88.26. So this ordinate is already 39.54. So what is the total ordinate? Total ordinate, it is 39.54 plus 88.26. ऍड केलं काय नाही केलं काय ते चालतंय. Now come back to this problem over here. So again, if I drop now perpendicular, this is the perpendicular. We have already calculated the ordinates. आत्ताच कॅल्क्युलेट केलंय आपण सगळं. ओके, सो this ordinate, it is how much? 88, and this ordinate is 39. Okay, so I will give the name here. Suppose now this is our point C, and this is D, this is E, this point is F, this point is G, and this point is H. Okay. एवढाच आहे ना आपला टो पोर्शन. This much is the toe portion. So area under that toe portion, that only we are going to consider. Okay. So here if I show you, हा तुमचा toe portion एवढाच आहे. This is your toe portion. This is 1 meter. This is 0.4 meter. This is only your toe portion. आणि ह्याच्या खाली जो ट्रॅपेझॉइडल तुमचा यायला लागलाय तो असा आहे. This is the trapezoidal. Okay. असा ट्रॅपेझॉइड आहे. त्याला तुम्ही डिवाइड केलं. You have divided this into triangle and rectangle. Okay. So now you have got this ordinate as 39.54. So this is also, this we have already calculated. This is I think 39.54. This is 132.4, and here this is at a distance of 3 meter. So now it is not a 3 meter distance. Okay. Tola. So this total is, what is the total ordinate? This 88 आणि हे किती येते total? 39.54 plus 88.26, 127.8. Okay, so this total ordinate, this total is 127.8. This is also 127.8. And this much remaining, it is minus 171. Okay. So this much we need to consider, and remaining this much, 132.4, whatever it may be. Okay. So now we have calculated this value. This below C, if you see here below C, this total ordinate we have calculated, and value of that ordinate was, what was the value? It was 127 point something, no? Let me know the values, fast type the values. 39.54 and then values 127.8. So this total ordinate it is 127.8. Okay. So now if I drop the perpendicular from this point now, here if you see from this point, this is the perpendicular. Okay. So now what is the remaining? This ordinate, remaining ordinate will be, this will become a triangle which I have shown in green. This will become a triangle. Okay. And now the second thing is in this yellow, whichever whatever I am showing, this will become a rectangle. So this will become a rectangle. And our point C is over here. This is our point C. So we will give some name to this. Let us, I will call this as C. This is D. Okay, this point is, I will call it as J. This point is F. Okay, and this green it is E. मग आता ट्रायंगलचा किती ऑर्डिनेट राहिला असेल? ट्रायंगलचा ऑर्डिनेट किती राहिला? हे टोटल 171 है ना, 171 point something minus 127.8. So calculate the total ordinate of triangle. हे काढून टाका, द्यायची काही गरज नाही. What is the ordinate of this triangle? 44.14. Okay. So this triangle ordinate is 44.14. Now we will calculate the upward pressure. So upward pressure, first this is CDJF, which is equal to, so what is this ordinate? 127.8 into, what is the length? This length 1 meter, 1 by 1. Okay, so 1, its length beyond it is also we have assumed 1 meter. Okay, beyond this is also 1 meter we have assumed. म्हणजे हा खालचा जो एरिया याची विड्थ किती झाली? 1 मीटर या एरियाची. कळतंय का? सो नाउ this is the upward pressure. So what is the magnitude? Magnitude we have got 127.8 kilonewton. Magnitude is in kilonewton. Then distance from point C. Distance from C. What is the distance? And then moment in kilonewton meter, and distance it is in meter. So the distance will be, what is the distance from point C? This is rectangle, this is 1 meter, so this is 0.5. This is 0.5 is the distance. So what is the moment? Calculate the moment. One 127.8 into 0.5, 63.9 ka? Okay, 63.9. 63.9. So this moment is, it is moving in, so upward pressure it is in clockwise direction. Okay, this is in clockwise direction. Next, second, this triangle now EFJ, which is equal to, याचा ऑर्डिनेट किती आलेला आहे? 44.14. So half into base into height. So half into base is this line. This is 1 meter into height. Height is 44.14. So it is 22.07. All please check the calculations. And now CG, the distance from point C. So point C म्हणजे इथं right angle आहे. So 2/3 of base. So 2/3 of 1. It is 0.66. It's 0.66. So this is 22.07 into 0.66. 14.56. Moment is 14.56. Again, this is clockwise moment because this is moving up. Now, if you see, this is the area of the toe slab, and the self weight of the toe slab will acting down, while these forces are acting up. Okay. Now consider the self weight. Now we will consider the self weight. So the self weight. Self weight किती आहे जर हे डिस्टन्स आहे 1. हे किती आहे? This is 0.4. It will be 1 into 0.4 into 25. So it is 10. CG कुठं हा सेंटरला ऍक्ट होणार आहे याच्या म्हणजे 1 च्या सेंटरला म्हणजे 0.5. So this movement is 5 kilonewton meter, but this is anti-clockwise. This is anti-clockwise. About point C, we should see the direction. About point C, this is our point C. Okay. So now the total moment. What is the total moment now? So the total moment will be sum of this. So the total moment is here 63.9, which is for same direction चे असले तर same sign द्या. Suppose it is clockwise, so plus 14.56. It is plus minus 5. So it is 73.46. It is 73.46 kilonewton meter. So this is our total moment for toe slab. This is our total moment for toe slab. मग या मोमेंटला आता स्टील प्रोव्हाइड करून टाकायचं. So now next is very simple. So bending moment at toe slab is equal to 73.46 kilonewton meter. So now we have to consider the effective cover for stem. We have provided 40 mm. Okay. Similarly, now we need to provide the effective cover for base slab. Okay. So here I will write considering 78 आएगा. Okay. 78.46. Okay. This value is 78.46. So considering effective cover for base slab as 60 mm. 60 mm we will consider the effective cover for the base slab. Therefore, capital D is equal to, we know that 400 mm. Capital D we know that it is 400 mm. Therefore, small d is equal to 400 minus 60, which is equal to 340 mm. Now AST is equal to 0.5 FCKBD divided by Fy in bracket 1 minus under root 1 minus 4.6 mu upon FCKBD square. This is the formula for AST. Now just put the values. B is 1000, D is 340, MU is also known to you. So just put the values. Therefore, AST is equal to zero point 0.5, FCK is 20, B 1000, D is 340 divided by 415, here in bracket 1 minus under root 1 minus 4.6 into 78.46 into 10 raised to 6 divided by FCK is 20, BD square, B and D square, it is 340 square. So after solving this, you will get the value of AST 666.58. आता बघा, हे जे एरिया ऑफ स्टील आहे आलेला, हा मिनिमम एरिया ऑफ स्टील पेक्षा जास्त पाहिजे तरच आपण हा प्रोव्हाइड करतो. नेहमी लक्षात ठेवा, whenever AST you are providing AST in any structure, आपण हा चेक कुठं पाठीमागे घेतलेला नाहीये, because I was sure whatever steel we have calculated it is greater than minimum steel, but always you should check AST for the minimum steel की आलेली AST ची व्हॅल्यू ही मिनिमम स्टील पेक्षा जास्त आहे का नाही. मिनिमम स्टील म्हणजे डिस्ट्रीब्युशन स्टील. जर मिनिमम स्टील पेक्षा जास्त असेल तर आपण ते स्टील प्रोव्हाइड करतो, जर मिनिमम स्टील पेक्षा कमी असेल तर आपण डिस्ट्रीब्युशन स्टील प्रोव्हाइड करतो. ओके, so now this is 666.58. now calculate minimum steel. Minimum steel, that is distribution, ह्यालाच आपण म्हणतो डिस्ट्रीब्युशन स्टील. मिनिमम स्टील कॅल्क्युलेट करा, किती येते. ASTD is equal to 0.12%, Fe415 is given by 100 into 1000 into 340. What is the answer? $408. Okay, so it is 408 mm. So here your AST is greater than ASTD. Okay, so therefore take AST is equal to, what was the value, 666.58 mm. Okay, now provide a 12 mm bar diameter. Provide 12 mm bar diameter. Provide. Now consider म्हणा, अजून प्रोव्हाइड कुठे केलाय. Consider 12 mm bar diameter. Okay. The number of bars, calculate now. Number of bars is equal to 6.58 divided by pi by 4 into 12 square. How many number of bars? 5.89. So 5.89, which is nearly equal to 6 numbers. So AST provided, calculate now. AST provided 6 into 5 by 4 into 12 square. 678.58. Okay. 678.58 mm square. Now calculate the spacing. Spacing S is equal to pi by 4 into 12 square divided by 678.58 into 1000. So let me know the answer. 166.67. 166.67, which will be round up to 160 mm center to center. So here provide 6 bars of 12 mm diameter. So provide 6 bars of 12 mm diameter about 160 mm center to center in toe slab. In toe slab. Okay. So this is the second part of this design of toe slab. Now third part we will see in the next lecture, design of hill, and after that there is a check, so that the design will over.